What if I told you that right now, at this very moment, there are objects humanity has already sent out into space that will never come back? Not because they ran out of fuel, not because they crashed, but because the laws of physics themselves make their return physically impossible. Welcome back to the channel. If you're new here, hit that subscribe button, because what you're about to learn will fundamentally change how you understand your place in the universe. But first, I need to know, where are you watching from right now? Drop your country and your time in the comments. I'm genuinely curious which parts of Earth are interested in why escape velocity is basically cosmic point of no return. And before we dive deep, give this video a like so more people can discover why we'll probably never see Voyager 1 come home. Here's the mind-blowing part most people don't realize. The solar system isn't actually holding on to our spacecraft with gravity alone. There's something far more sinister at work, something Einstein discovered over a century ago that makes leaving the solar system a genuinely one-way ticket. And today, we're going to understand exactly why. Let's start with something you think you understand. Gravity. You learned it in school. Objects fall down. Apples fall from trees. The Earth pulls things toward it. Simple, right? Here's what will blow your mind. Gravity isn't actually a force pulling you down at all. In 1915, Albert Einstein published his general theory of relativity, and it fundamentally rewrote our understanding of gravity. Einstein showed that massive objects don't pull on things. They actually bend the fabric of space and time itself, like a bowling ball creating a dip in a rubber sheet. You're not being pulled toward Earth. You're actually following the curved geometry of space around our planet. Think of it like this. Imagine walking on a hill without realizing it's a hill. You keep walking straight, but the ground curves beneath you, so you end up lower. That's gravity. Now, here's where it gets interesting. A scientist named Carl Schwarzschild took Einstein's equations just a few months later and solved them for a point that changed everything. He discovered something called the Schwarzschild radius, the distance at which gravity becomes so intense that not even light can escape. In 1939, physicists had the courage to name these black holes. But that's not what we're talking about today, though it will matter later. What matters now is understanding that gravity isn't something you escape, it's something you have to climb out of. Every massive object in the universe creates a gravity well, and leaving that well requires energy. Lots of it? Think about throwing a ball up in the air. Throw it gently, it comes back down. Throw it harder, it goes higher before gravity pulls it back. Throw it hard enough, and there's a specific speed where it would never come back. That speed is called escape velocity, and it's the first key to understanding why leaving the solar system is a one-way trip. For Earth, escape velocity is about 11.2 kilometers per second. That's roughly 40,000 kilometers per hour. The fastest commercial airplane reaches maybe 900 kilometers per hour. We'd need a spacecraft moving 44 times faster than the Concorde. But here's the retention hook. Earth's escape velocity is just the beginning of the problem. And every word I'm about to say next will make you realize why rockets heading out of the solar system face an enemy far more powerful than gravity alone. Most people think about escaping Earth's gravity and imagine they're free. But you're not free. You've just moved one prison to another. The sun owns you now. Here's a question that will test whether you're actually understanding this. If I launch a rocket fast enough to escape Earth, does it automatically escape the sun's gravity too? The answer might surprise you. No, not even close. In 1969, when we sent humans to the moon, we didn't escape the sun. When in 2012, the Curiosity rover landed on Mars, it didn't escape the sun. Even the Voyager spacecraft, the fastest things humanity has ever created, are still traveling through the sun's gravitational field. They're following an orbit, just an incredibly elongated one. Think of it like this. Imagine the entire solar system is a bathtub, and the sun is a drain. Planets orbit around the drain, like water circling before it goes down. When you throw something faster and faster, you're not escaping the drain. You're just making the circle bigger and bigger, stretching out until it becomes so enormous, it looks almost like a straight line. This is where Robert Goddard comes in. In 1919, this American physicist proved that rockets could work in the vacuum of space, that they didn't need air to push against. Everyone thought he was crazy. The New York Times literally called him ignorant of physics. But Goddard understood something revolutionary. Anything you send out of the solar system has to have enough energy to overcome the sun's gravitational binding energy. The sun's escape velocity, the speed you need to be traveling to escape the sun's gravity, entirely from Earth's orbital distance, is about 42.1 kilometers per second. Not per hour. Per second. We're talking about speeds that are nearly 4 times faster than Earth's escape velocity. Here's what will absolutely blow your mind. Voyager 1 is traveling at about 17 kilometers per second. That's incredibly fast. In 1977, when it launched, it was the fastest thing humanity had ever built. But it's still only about 40% of the speed needed to escape the sun's gravity from where it started. And yet Voyager 1 is actually leaving the solar system. How is that possible? The answer involves something called a gravity assist, and this is where the story gets almost poetically interesting. In the 1960s, Michael Minovich discovered that if you use the gravity of planets themselves, you can get nearly free speed boosts. When Voyager 1 passed by Jupiter, Saturn, Uranus, and Neptune, these massive worlds bent its trajectory and gave it additional velocity without using any fuel. It's like jumping off a moving train while it's going faster than you could run. The train gives you that extra speed for free. This discovery made the mission possible. But here's the retention hook that will make everything click into place. Even with these gravity assists, even moving at incredible speeds, Voyager 1 is still not moving fast enough to completely escape the sun's gravitational influence. It's escaping the inner solar system. Yes, it will eventually leave the region where planets orbit. But the sun will always have its hands on Voyager 1, gently pulling it back, slowing it down infinitesimally with gravity that never truly ends. What this means is almost philosophically profound. Nothing humanity has ever created will ever truly stop feeling the sun's pull. We can stretch that pull out over impossible distances, but we cannot break it. The solar system is not a place you leave. It's a gravity well you escape from, but escape is not binary. It's a spectrum, and true escape might be fundamentally impossible. Now that you understand escape velocity and gravity assists, I need to introduce you to something that will reframe everything: the Oort cloud. What if I told you that the solar system is almost incomprehensibly larger than you think? That everything we've discussed so far is just the innermost layer of something almost impossibly vast? The Oort cloud is a theoretical sphere of icy bodies surrounding our solar system. We've never seen it directly because it's too far away and too dark. But we know it exists because of comets. In 1950, Jan Oort made an observation that changed everything. He noticed that some comets seemed to come from all directions in space, not from a particular plane. He calculated that these comets had to originate from a spherical cloud surrounding the solar system, extending nearly halfway to the nearest star. Think of it like this. If the solar system were the size of a marble, the Oort cloud would be a sphere with a diameter of several city blocks surrounding it. Earth would be an invisible speck on that marble. The planets that dominate our news, that seemed so far away, would be completely invisible at that scale. The Oort cloud might extend up to 200,000 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun. So we're talking about a sphere that might be 400,000 astronomical units in diameter. That's roughly 60 trillion kilometers in every direction. Here's the mind-blowing part. Voyager 1, traveling at 17 kilometers per second, the fastest thing humanity has made, would take roughly 70,000 years just to reach the inner edge of the Oort cloud. And that's one way. 70,000 years to travel to the edge of what most people still consider our solar system. This is where the true horror and wonder of escape velocity becomes apparent. Voyager 1 has enough energy to eventually leave the gravitational influence of the Sun. Scientists believe it will escape sometime in the next few million years. But the Oort cloud isn't a barrier made of matter. It's a conceptual boundary. What matters is that the Sun's gravity becomes so weak at those distances that other forces begin to matter. Let me introduce you to the second barrier, stellar gravity. The nearest star to Earth, Proxima Centauri, is about 4.24 light-years away. That's 40 trillion kilometers. It might seem impossibly far, but here's what will fundamentally change how you think about cosmic neighborhoods. Proxima Centauri's gravity is already pulling on the Oort cloud. The Oort cloud isn't just under the Sun's gravitational influence. It's in a tug-of-war between the Sun and the nearest stars. Some objects in the outer Oort cloud are pulled more toward Proxima Centauri than toward the Sun. This is the retention hook you need to understand. The solar system doesn't have a clear boundary. It fades into neighboring star systems gradually, with gravity fields overlapping and competing. Now we need to have a serious conversation about energy. Because leaving the solar system isn't just about breaking free from the Sun's gravity. It's about the fact that leaving is exponentially harder than we think. Here's a question. If you need velocity v to escape the Sun from Earth's orbit, how much more velocity do you need from a different distance? The answer reveals the cruelty of physics. Remember escape velocity? It's calculated by the formula. V equals square root 2gmr, where g is the gravitational constant, m is the mass of the object, and r is the distance from its center. Notice that distance appears in a denominator under a square root. This means escape velocity doesn't decrease linearly with distance. It decreases with the square root of distance. Think of it like this. If you double your distance from the Sun, the escape velocity doesn't drop to half. It drops to roughly 70%. If you triple your distance, it drops to 58%. You have to go incomprehensibly far away before escape velocity becomes negligible. In 1687, Isaac Newton published the Principia Mathematica, laying out the laws of motion and universal gravitation that governed all of this. Newton never knew about escape velocity explicitly. He was working out the mathematics that would eventually lead to the concept. But his third law, every action has an equal and opposite reaction, is the fundamental reason rockets work at all. When Voyager 1 launches its rocket engines, it's literally pushing matter backward to accelerate forward. Every ounce of fuel it burns is mass it has to accelerate. And the farther it gets from the Sun, the more fuel it would theoretically need to accelerate further. But here's the profound part. Voyager 1 burned its thrusters on its journey out of the solar system. It's coasting now. No more fuel. No more acceleration. This is what will blow your mind about space travel. Once you're beyond a certain point, you can't accelerate anymore. You're committed to your current velocity. Voyager 1's future, its ability to escape or its destiny to be recaptured, was essentially sealed decades ago when those thrusters burned for the last time. Think of it like this. Imagine you're on a train and you have a limited amount of coal to burn. You need to reach the top of a mountain pass, or you'll roll backward. You burn your coal, accelerating the train and climbing. But then you realize you're not at the summit yet. You'll never have enough coal to burn to reach it. At some point, you have to accept that your coal is gone, and whatever momentum you have is all you're ever going to have. That's Voyager 1. That's every spacecraft humanity has ever sent beyond Earth. The retention hook here is disturbing and beautiful. We've already made our choice about which spacecraft will escape the solar system and which will not. Decades ago, when those engines burned for the last time, the future of these objects was determined by physics. Some of them will drift through space until the Sun itself dies. Others might eventually be captured by a passing star, but none of them will ever return to us. I told you earlier about gravity assists, and I need to complicate that story because the real physics is far more interesting than I initially explained. Michael Minovich discovered gravity assists in 1961 while he was still a student. His insight was elegantly simple. If you're in the gravity well of a massive object, you can gain speed without using fuel. You just have to be moving in the right direction relative to that object. But here's what most people don't understand. Gravity assists work because of something called the Oberth effect. When you're deep in the gravity well of a massive object, accelerations have exponentially more effect. If you accelerate a little bit while you're close to Jupiter, you gain far more energy than accelerating the same amount far from Jupiter. Think of it like this. Imagine you're going down a ramp on a skateboard. If you push off hard at the top of the ramp, your speed barely increases. But if you push off with the same force at the bottom of the ramp, your speed increases dramatically. That's the Oberth effect. Gravity wells are like ramps. The closer you go to them, the more effective your acceleration becomes. This is why Voyager's mission was designed so precisely. The spacecraft followed what's called the Grand Tour, a rare alignment of planets that happens only once every 176 years. In the 1970s, Jupiter, Saturn, Uranus, and Neptune were positioned such that Voyager could gravity assist off each one in sequence, gaining energy from each gravitational interaction. This was a one-time opportunity that wouldn't come around again for centuries. And here's what will absolutely blow your mind. This mission is the reason Voyager 1 can leave the solar system at all. Without those gravity assists, it wouldn't have enough energy. But gravity assists only work if you use them when the planets are in the right position. Miss that window, and you can't go back and do it again. The gravitational alignment won't happen for another 176 years. This is philosophical horror dressed up as physics. We sent Voyager on a specific trajectory determined by planetary positions that recur once per human civilization's lifetime. If we had missed that window by a few years, the spacecraft wouldn't have enough energy to escape the solar system at all. We succeeded because of a cosmic coincidence, not because of our technological prowess. But there's another layer to this story that will reframe what escape velocity even means. As Voyager 1 travels away from the Sun and the planets, it's being decelerated by the Sun's gravity. That escape velocity formula I told you about? It assumes you're doing all your accelerating at a specific location. But in reality, Voyager is accelerating and then coasting while gravity decelerates it. What this means is that the spacecraft needs to achieve escape velocity not from its current position, but from its maximum distance. If Voyager could somehow be measured at the moment it's infinitely far from the Sun, its velocity at that point determines whether it truly escaped. If that velocity is above zero, it escaped. If it reaches zero velocity before escaping, gravity will pull it back. The calculations show that Voyager 1 will indeed have a small amount of velocity remaining when it reaches infinity. It will escape. But listen to how small that margin is. The difference between Voyager 1 being bound to the Sun forever and being free is a matter of a few kilometers per second in a velocity measured in the past, applied to calculations made decades ago. Here's the retention hook that ties everything together. Gravity assists work, but they work because you're essentially borrowing energy from planets. You're trading orbital energy with massive objects. And the catch is that this trade only works when the planets are positioned correctly. The universe doesn't care about our schedules. It runs on its own timeline. We succeeded at escaping because we understood these principles and because we got lucky with the cosmic alignment. Now I need to introduce something that will make escape velocity seem like the least of our problems: relativity. Specifically, I need to talk about time dilation, which is Einstein's hidden constraint on space travel. In 1905, Einstein published his special theory of relativity. Most people focus on E equals mc, or the fact that nothing can travel faster than light. But there's another aspect that's crucial for understanding why leaving the solar system is truly a one-way trip: Time itself is relative. When something travels at a significant fraction of the speed of light, time passes differently for it than for stationary observers. This isn't a metaphor. It's not a theory that's been debunked. This is how reality works. We've measured it. We've tested it. Atomic clocks flown on airplanes run slower than identical clocks on Earth. The difference is tiny but measurable. Think of it like this. Imagine two twins. One stays on Earth. One travels in a spaceship near the speed of light. When the spaceship returns, the traveling twin is younger than the one who stayed behind. That's not science fiction. That's relativity. Now here's what will blow your mind. Voyager 1 is traveling at about 17 kilometers per second. That's roughly 0.006% the speed of light. At this speed, time dilation is completely negligible. To the atoms and structures making up Voyager 1, time is passing at essentially the same rate as it passes here on Earth. But I'm bringing up time dilation because it represents a cosmic speed limit. As anything approaches the speed of light, it would require infinite energy to accelerate further. This is because relativistic mass increases with velocity. The faster you go, the more massive you become, and the more energy it takes to accelerate further. What this means is that there's no way to escape not just the sun's gravity, but the galaxy's gravity using conventional rocket technology. The Milky Way is about 100,000 light-years in diameter. Its gravitational field is enormous. To truly escape the galaxy, an object would need to be traveling at nearly the speed of light, a speed that would require more energy than exists in the observable universe to achieve using classical methods. This is where things get truly philosophical. There are two escape velocities relevant to humanity: the sun's escape velocity and the galaxy's escape velocity. Voyager 1 will escape the sun's gravity, but it will never escape the galaxy's gravity. In fact, nothing we've ever built, and nothing we're ever likely to build with conventional technology, will escape the Milky Way. In 2012, a physicist named Michael McCulloch proposed a theory called modified Newtonian dynamics, MOND, that might explain some anomalies in how galaxies move. His work hints at deeper principles we don't yet understand about gravity. The point is that physicists are still discovering that gravity might be subtler and more complex than Newton and Einstein imagined. The retention hook here is cosmic in scope. Leaving the solar system is possible. Leaving the galaxy is practically impossible. And leaving the universe itself? That question might not even make sense. Now we need to get personal, because understanding why leaving the solar system is one way isn't just academic. It's profoundly relevant to who you are and where you belong. Think about the last time you felt truly connected to the Earth. Maybe it was watching a sunset. Maybe it was swimming in the ocean. Maybe it was just breathing fresh air. That feeling of connection isn't poetic fancy. It's biology recognizing its origin. Every atom in your body was forged in stars. This isn't metaphorical. In 1957, a physicist named Fred Hoyle and his colleagues figured out how elements are created. Inside stars, hydrogen fuses into helium, then helium into carbon and oxygen, then heavier elements up the periodic table. When massive stars explode as supernova, they scatter these elements across space. Those elements form planets. On one planet, those atoms assembled into life, then into you. You are made of star stuff, literally. The calcium in your bones, forged in stars billions of years ago. The oxygen you're breathing, created in the core of a dying star. The iron in your blood, synthesized in a supernova explosion before our solar system was even born. This means something profound. You are not separate from the solar system. You're not trapped in it. You're part of it. You're an expression of it. Now think about Voyager 1 again. It's traveling at 17 kilometers per second toward the stars. In about 40,000 years, it will pass within 1.6 light-years of Proxima Centauri, the nearest star to our sun. By then, its instruments will be dead. Its power source, a radioisotope thermoelectric generator powered by plutonium, 238 decay, has a half-life. In about 50 years, the spacecraft won't be able to transmit anymore. After that, Voyager 1 will be silent. But it won't be alone. On Voyager 1, there's a golden record. This record contains sounds and images from Earth. It contains music. It contains the greetings of world leaders and scientists. It contains a message from Secretary General Kurt Waldheim, a meditation from the Dalai Lama, and music ranging from Bach to Chuck Berry. In a very real sense, Voyager 1 carries a piece of you into the cosmos. Your consciousness, expressed through human creativity and culture, is bound for the stars on a spacecraft you'll never meet. That's not science fiction. That's happening right now. The mind blow is this. Voyager 1 might never return to the solar system, but it's taking Earth with it. It's taking humanity. It's taking you. Think about what this means psychologically. You are connected to something larger than yourself. You are part of a species that has the audacity to throw caution to the wind and send messages to the stars on the chance, the infinitesimal chance that someone might find them, that you might find them. But here's the twist that will reframe your entire understanding of one-way trip. Is Voyager 1 really leaving the solar system? Or is the solar system extending through Voyager 1? Is the boundary between the solar system and the rest of the galaxy actually real? Or is it just a convenient fiction we created to help us think about distances we can barely comprehend? If the solar system is defined by the sun's gravitational influence, then Voyager 1 will never truly leave. It will just drift farther and farther until the sun's influence becomes imperceptible. In a way, the solar system is expanding with every second that Voyager 1 travels. Our home is bigger than we think, and it's getting bigger all the time. There's another reason why leaving the solar system is a one-way trip that's even more fundamental than gravity. It's called the second law of thermodynamics, and it might be the most important law in all of physics. The second law of thermodynamics states that entropy always increases. In other words, disorder always increases. Chaos always wins. This isn't just true for physics. It's true for information, for chemistry, for everything. Think of it like this. Imagine a room filled with both hot and cold air. Over time, heat transfers from hot regions to cold regions. Eventually, the entire room reaches the same temperature. You can never spontaneously have the hot and cold air separate again without adding energy from outside the system. That's entropy. Ludwig Boltzmann formalized this in 1877, and it changed how we understand the universe. He showed that entropy is related to probability. States of high entropy are more probable because there are more ways to arrange the universe in a disordered state than in an ordered one. Now, why does this matter for leaving the solar system? Because rockets work by converting concentrated chemical energy into directed kinetic energy. When you burn rocket fuel, you're taking highly ordered chemical bonds and breaking them, releasing energy in the process. That process increases entropy in the universe overall. When Voyager 1 fired its thrusters, it was increasing entropy. It was taking ordered energy and converting it into less ordered forms. The heat from the engines dispersed into space. The kinetic energy given to the spacecraft was purchased by increasing disorder elsewhere in the universe. This is where it gets philosophical. Once you've spent that energy, you can never get it back. You can never undo it. Entropy never decreases in a closed system. This means that every rocket burn that accelerated Voyager 1 has permanently, irreversibly pushed it in a specific direction. You cannot burn the same fuel twice. You cannot gain back the energy you spent. In 1869, Rudolf Clausius developed the concept of entropy, symbolized as S. The second law can be expressed mathematically as ds is greater than or equal to 0. The entropy of the universe never decreases. This means that the future is fundamentally different from the past in a way that has nothing to do with our perception or memory. The second law creates an arrow of time. Here's what will blow your mind. Because of the second law of thermodynamics, Voyager 1 cannot return. Even if we could somehow reverse gravity, even if we could reverse the orbital mechanics, we cannot reverse the entropy that was created when we launched it. Every joule of energy we spent to accelerate Voyager 1 was an irreversible change to the universe. This is why leaving the solar system is literally, fundamentally, thermodynamically, a one-way trip. It's not just the engineering. It's not just the gravity. It's woven into the fabric of reality itself. The universe has a direction. And that direction has carried Voyager 1 away from home in a way that can never be undone. The retention hook is almost existential. Every journey has a cost in entropy. Every trip you take, every movement you make, generates disorder in the universe. This is why time seems to move in one direction. This is why you can remember the past, but not the future. This is why death exists and life is temporary. The second law of thermodynamics is why leaving is inevitable and return is impossible. Now, I want to introduce you to a concept that will make you realize. Voyager 1 is far more remarkable than you thought. Gravitational memory. And I need to explain a physicist who revolutionized how we think about gravity. In 2016, physicist Juan Martin Maldacena proposed something called the ADSC-FT correspondence. Without getting too deep into the mathematics, his work suggested that information might be fundamentally encoded in gravity itself. When something falls into a black hole, or when something is accelerated and sent into space, it leaves an imprint on space-time itself. Think of it like this. Imagine the universe is a hologram. Everything that happens, every acceleration, every gravitational interaction is recorded on the boundary of that hologram. Information doesn't disappear. It's encoded into the structure of space-time. Now, this is speculative physics. It's not proven, but it hints at something profound. Voyager 1's journey is not merely a spacecraft moving through empty space. It's a ripple in space-time. It's information being encoded into the fabric of reality itself. In 1974, Stephen Hawking made a discovery that shook the foundation of physics. He showed that black holes aren't completely black. They radiate energy. They lose mass over time. Hawking showed that information might escape from black holes as radiation. But he also showed that if information is conserved, it must be encoded in that radiation in ways we can't currently decode. What this means for Voyager 1 is almost poetic. Even if we could never intercept it, even if it drifted silently into the darkness forever, the information about where it is, what it contains, and what messages it carries is still part of the universe. It's encoded in the gravitational field. It's written into space-time. In a very real sense, Voyager 1 cannot disappear. It will always be part of the cosmic story. Long after its power dies, long after its radio signal fades to nothing, the fact of its existence will remain encoded in gravity itself. Future civilizations, if they're sophisticated enough, might be able to read that gravitational information the way we read radio waves. They might know that Voyager 1 passed through their neighborhood, even if we've long since gone extinct. The mind-blowing part is this. Leaving the solar system is a one-way trip in terms of returning here, but it's not a one-way trip in terms of being forgotten. Your message, humanity's message, encoded on the golden record, will persist in the universe forever. The universe itself is keeping track. The retention hook here is both humbling and empowering. You don't have to be here for your impact to matter. You don't have to return to matter. Voyager 1 doesn't need to come back to Earth to have changed the universe permanently. Neither do you. I need to get really personal now, because understanding why we can't leave the solar system is intimately connected to understanding why we can't leave our own lives, and why that's not actually a tragic thing. Every person has an escape velocity, not from gravity, but from their circumstances. Most people feel trapped by their situation. They think if they could just escape, change jobs, move to a new place, find a new relationship, everything would be different. They think escape is possible. But here's the truth that will reframe your entire life. You're not trapped in a gravity well that you need to escape. You're woven into a gravitational field that defines who you are. Your family is part of your gravity well. Your culture is part of your gravity well. Your memories are part of it. Even your suffering is part of the structure that makes you capable of joy. Voyager 1 was designed to escape, but it didn't become less itself by doing so. It's still the same spacecraft. It still carries the same message. Escaping the solar system didn't change what Voyager 1 is. It changed its location and its trajectory, but not its essence. In 1938, physicist Richard Feynman gave a lecture on the nature of physical law. He said that the beauty of physics isn't in understanding nature as a collection of separate things, but in understanding the connections between them. In understanding that everything is part of a unified whole. You are connected to Earth by gravity. That's true. You're connected to your family by chemistry and culture. You're connected to all humanity by the fact that you're made of the same atoms that have been recycled through billions of lives. You're connected to the stars by the fact that your atoms were forged in them. These connections aren't limitations. They're the structure that makes you real. They're what gives you meaning. Think about what would happen if you could truly escape. If you could break free of all connections, all gravity wells, all relationships, you would become isolated. You would be alone. That's not freedom. That's oblivion. The mind-blowing revelation is this: the only way to truly escape would be to become nothing. And becoming nothing would mean you couldn't experience the escape. The only form of escape that exists is the one where you remain connected to what you're escaping from. You just move farther away. This is the profound metaphor that Voyager 1 gives us. Leave, but don't forget where you came from. Travel, but carry your message with you. Escape, but maintain your connection. Be far away, but still part of the system that created you. The retention hook that will reshape how you think about your own life. You don't have to choose between escape and connection. Voyager 1 did both. It escaped the solar system while carrying Earth with it. You can do the same. You can move forward in your life, grow beyond where you started, but you don't have to sever the connections that make you who you are. In fact, the deepest growth comes from moving away while staying connected. That's what makes it meaningful. That's what makes it possible. Now I need to challenge something fundamental that we've been assuming this entire video, that the solar system has a real boundary at all. Because here's what will blow your mind, it might not. In 1992, astronomers discovered something that changed our understanding of the solar system completely. They found an object beyond Neptune called 1992 QB1. This was the first discovery of what we now call the Kuiper Belt, a region full of small icy bodies orbiting the Sun. Suddenly, the solar system was much bigger than we thought. Pluto wasn't the edge. It was just the most famous object in a region full of thousands of dwarf planets and comets. But then it got more complicated. In 1950, Jan Oort theorized the existence of the Oort cloud, the sphere of icy bodies I mentioned earlier, that extends up to 200,000 astronomical units from the Sun. Then, in Geis 1995, astronomers discovered the first exoplanet, a planet orbiting a different star. And they realized something troubling. Planets orbit other stars the way comets orbit ours. What if the solar system doesn't actually have a boundary at all? What if it's just a gradient? What if, as you travel away from the Sun, its gravity fades, but it never actually becomes zero? It just becomes smaller and smaller, weaker and weaker, until other gravitational influences become relatively more important. In 2008, physicist Jeffrey West published work showing that complex system cities, organisms, companies, don't have sharp boundaries. They have fuzzy, fractal boundaries where the system slowly blends into the environment. Is a city really bounded by its political borders, Or does it fade gradually into suburbs and the countryside? The solar system might be the same way. It doesn't end, it fades. Voyager 1 isn't leaving the solar system on a specific date. It's slowly moving from a region where the sun's gravity is dominant to a region where other stars' gravity becomes more important. The mind-blowing part is this. In some sense, Voyager 1 is always in the solar system because the sun's gravity never truly becomes zero. It just becomes negligible. And in another sense, Voyager 1 left the solar system long ago because we define it functionally by the region where planets orbit and comets are thought to originate. This is the revelation that reframes everything. The one-way trip isn't from inside to outside a defined space. It's a gradual fade from one gravitational dominance to another. The boundary exists only in our minds as a convenience for thinking about cosmic distances. The universe doesn't actually care about our categories. It doesn't recognize our boundaries. It just follows the laws of physics, which are continuous and smooth. There are no absolute edges. There are only gradients of influence fading into each other. The retention hook here is epistemological. We create categories to make sense of the universe, but the universe doesn't care about our categories. The solar system is real. It's a real region of gravitational influence. But it's also kind of imaginary. It's a boundary we drew on the cosmos for our own convenience. Leaving the solar system is real and unreal at the same time. It's a one-way trip into a region we don't fully understand, to a boundary that might not actually exist. Now I need to talk about where we go from here, because understanding why leaving the solar system is a one-way trip with current technology doesn't mean it will always be impossible. Right now, Voyager 1 is powered by heat from plutonium-238 decay. That power source will be dead in about 50 years. After that, Voyager 1 will coast silently, sending no messages, receiving no commands. It will become an ancient ruin, a ghost of human ambition drifting through the void. But what if we could build a spacecraft with a different power source? What if we could harness the energy of the sun, even from far away? What if we could use methods we haven't even invented yet? In 1960, Robert Ford proposed something called a laser-pushed sail. The idea is elegant. A powerful laser here on Earth sends a beam of photons across space. The photons carry momentum. If a spacecraft has a reflective sail, those photons bounce off it, pushing it forward. This could theoretically accelerate a spacecraft far beyond what chemical rockets could achieve. The Breakthrough Starshot project, announced in 2016, is designed to use this principle. The goal is to send tiny spacecraft, each about the size of a postage stamp, to another star system. They would be accelerated by powerful lasers to 20% the speed of light. At that speed, it would take about 20 years to reach Proxima Centauri. But even this isn't enough to truly escape from a gravitational perspective. Reaching another star is impressive, but other stars have gravity too. To truly escape the galaxy, you would need to reach speeds close to the galaxy's escape velocity speeds that approach the speed of light itself. This is where things get speculative. In 1973, Freeman Dyson proposed the concept of a Dyson sphere, a structure built around a star to capture all of its energy output. If we could harness a star's power, could we use that power to accelerate in new ways? And then there's the realm of purely theoretical physics. In 1994, physicist Miguel Alcubierre proposed a mathematical solution to Einstein's field equations that would allow faster-than-light travel without violating relativity. It involves warping space-time itself, creating a bubble of contracted space ahead of a spacecraft and expanded space behind it. Alcubierre drive space-time warp hasn't been built. We don't know if it's physically possible. It might require more energy than the universe contains. It might require exotic matter with negative energy density that we don't know how to create. But mathematically, it's not ruled out by the laws of physics. The mind-blowing part is this. Every barrier we've discussed escape velocity, the speed of light, Thermodynamic limitations might be surmountable with future technology. The reason leaving the solar system is a one-way trip right now is because we have limited technology and limited energy. But that limitation is ours, not the universe's. In 2012, physicist Harold White at NASA proposed modifications to Alcubierre's equations that might reduce the energy requirements for a warp drive. He suggested it might be possible with energy equivalent to the mass energy of Jupiter. That's still an incomprehensible amount of energy, but it's not infinity. It's theoretically possible. The retention hook is hopeful and realistic. We can't leave the solar system and return right now. But future civilizations with vastly more advanced technology might be able to do things we consider impossible. They might discover principles we haven't yet understood. They might engineer solutions we haven't yet imagined. Leaving the solar system is a one-way trip today, but tomorrow is always coming. I need to bring this full circle back to you, because everything we've discussed has been leading to a simple but profound truth about who you are and why this matters. You are made of atoms that have been on a journey far longer than human civilization. Those atoms have traveled through stars, through planets, through countless organisms. Every atom in your body is between 4 and 13 billion years old. You are not a temporary arrangement of matter. You are a reunion of ancient travelers meeting once more, briefly, before scattering again. The iron in your blood was forged in a star that exploded before our solar system was born. The carbon in your cells was created in a dying star's core. The oxygen you're breathing entered existence in a stellar furnace billions of years before life on Earth existed. When Voyager 1 leaves the solar system with its golden record aboard, it carries your voice into the cosmos. Not metaphorically. The sounds and images on that record represent human consciousness. Your consciousness, expressed through your species' achievements and art and dreams. Think about what this means. You will have a presence beyond Earth. Not through physical travel, but through the information you've created and the messages you've sent. The Voyager Golden Record contains the song Beethoven's First Symphony. Beethoven is dead. His civilization is dust. But the pattern of sound waves he created is traveling toward the stars. You're doing the same thing, whether you realize it or not. You're creating patterns. You're creating information. You're creating ripples in reality that will persist long after you're gone. In 1978, astronomer Carl Sagan, who co-created the Voyager Golden Record, wrote, "The Earth is a very small stage in a vast cosmic arena." He understood something fundamental. The cosmos is incomprehensibly large, but that doesn't make your existence small. It makes it precious. It makes it rare. It makes it significant. You are part of the universe experiencing itself. You are how the cosmos has become conscious. You are how matter has learned to wonder about its own nature. That's not poetic fancy. That's what consciousness is, the universe knowing itself from the inside. Here's what will reframe how you see your significance. Right now, at this moment, you are doing what Voyager 1 is doing. You're traveling through space at 30 kilometers per second. That's Earth's orbital velocity around the sun. You're moving away from where you've been, toward where you'll be. You're on your own cosmic journey, moving through a gravity well, subject to forces you barely comprehend. The question isn't whether you can escape. The question is whether you'll travel consciously, carrying your message, staying connected to your origins while moving toward the future. That's what makes the journey meaningful. That's what made Voyager 1 significant. Not that it escaped, but that it carried something of Earth with it. The retention hook is personal. You are not separate from this story. You are the story. You are the consciousness that's wondering about the cosmos. You are the awareness that wonders why leaving is a one-way trip. And that wondering itself, that capacity to ask questions about the nature of reality, is perhaps the most significant thing the universe has created. Let's synthesize everything we've learned, because the full picture is far more profound than any single piece. Leaving the solar system is a one-way trip for multiple, interconnected reasons that operate at every level of reality. First, there's gravity escape. Velocity increases with the inverse square of distance. You need more speed to leave from farther away. The sun's gravity never truly becomes zero, so technically nothing ever truly escapes. Though trajectories can become so elongated, they become effectively escape. Second, there's energy conservation and the Oberth effect. To accelerate far from the sun is exponentially less efficient than accelerating near it. Once you've spent your fuel, you're committed to your trajectory. There's no going back to accelerate again. Third, there's time and entropy. The second law of thermodynamics means that every joule of energy you spend increasing a spacecraft's velocity is an irreversible change to the universe. You cannot undo it. The past and future are fundamentally different because of the arrow of entropy. Every rocket burn that sent Voyager 1 toward the stars was a thermodynamic irreversibility. Fourth, there's relativity. The closer you approach the speed of light, the more energy it takes to accelerate further. True escape from the galaxy, not just the solar system, would require speeds approaching the speed of light, an achievement requiring godlike control of energy. Fifth, there's the fuzziness of boundaries. The solar system doesn't have a sharp edge. It fades. The question of whether you've left the solar system depends on how you define solar system. The boundary is real, but also somewhat arbitrary. But here's the most important part. All of these barriers are barriers for objects with current human technology. Future civilizations might develop methods we can't currently imagine. Warp drives might be possible. Exotic matter might exist. New principles might be discovered. What Voyager 1 proves is that leaving is possible. It shows that even with primitive technology by future standards, we can reach the boundaries we thought were permanent. It shows that determination, intelligence, and clever use of physics can overcome seemingly impossible odds. Now, let's connect this to you personally. You are in a gravity well. You're in multiple gravity wells, the Earth's, the Sun's, the galaxies. You're also in metaphorical gravity, wells the pull of habit, of expectation, of what others think you should do. Just like Voyager 1, leaving these gravity wells is possible, but it requires energy. It requires planning. It requires sometimes accepting help from unexpected places, gravity assists from mentors, teachers, friends, parents who boost your trajectory. It requires acknowledging that some of these gravity wells aren't prisons, they're your home. The profound realization is this: you don't have to escape everything to grow. Voyager 1 didn't have to sever its connection to Earth to become remarkable. You don't have to either. You can grow within your connections. You can change your trajectory while still being woven into the fabric of your origins. Think about what Voyager 1 carries, the golden record. It carries Bach and Beethoven and the sounds of whales and thunder. It carries greetings in multiple languages. It carries the consciousness and culture of Earth, even as it leaves Earth behind. This is the model for meaningful change. Carry what matters with you, even as you move beyond it. The one-way trip isn't tragic because it's not a running away. It's a running toward. Every moment you're moving from where you were toward where you'll be. That trajectory is determined by your past velocity and the gravitational influences acting on you. But it's not determined by them completely. There's always a choice about how much energy you'll invest, what gravity assists you'll accept, what direction you'll aim. When you understand why leaving the solar system is impossible to reverse, you also understand something crucial. Impermanence is not tragedy. Change is not loss. Moving forward is not abandoning. Every moment of your life, you're leaving behind where you were. You're becoming farther from your childhood, your past selves, the moment you just experienced. That's not sad. That's how time works. That's how growth works. Voyager 1 will never come back. It will never orbit Earth again. But it will always be part of Earth's story. It will always be humanity's messenger. Its journey is complete the moment it leaves, And it's also never complete, because it travels forever. Your life is the same way. The journey doesn't need an endpoint. The meaning doesn't require return. Every moment of your existence is both complete and ongoing. You are both leaving and arriving simultaneously. You are moving through the cosmos at fantastic speeds, carried by forces you didn't choose, but you're also consciously directing your trajectory moment by moment. Here's what will blow your mind about your own existence. Right now, at this very moment, you are Voyager 1. You are the consciousness traveling through a gravity well, carrying a message into an uncertain future. You are the physical matter that was forged in stars. You are the awareness wondering about its own nature. You are the connection between Earth and the cosmos. When you ask why we can't come back, you're asking the deepest question a conscious being can ask. What is my home? The answer is everything. Your home is the solar system, yes, but also the galaxy, and also Earth, and also the specific place you're sitting reading this, and also the people you love, and also your own mind, where these ideas are forming right now. You don't need to escape your home. You need to understand that your home is larger than you thought. You are connected to everyone and everything through chemistry and gravity and the shared fact of existence. That connection is not a limitation. It's your significance. Leaving the solar system is a one-way trip, and so is being alive. You left the moment you were born. You'll leave every moment you've ever experienced. That one-way trajectory is where your power lies. You can't go back. You can only go forward, consciously choosing your direction, accepting help from the gravity of people who love you, carrying your message into a future you'll never see. The Voyager spacecraft will outlive humanity. It will outlive Earth. It will outlive the sun. It will continue its trajectory long after everything we've built has turned to dust. But the message on the golden record human consciousness, human creativity, human love that will persist. You have the same opportunity, not to escape the solar system, but to escape the limitations you've placed on yourself. To understand that your connections are not chains but roots, and roots can grow anywhere if you choose to move them towards sunlight. When you leave home, whether that's leaving for college, leaving for a new job, leaving for a new chapter of your life, you're not abandoning your origin. You're extending it. You're continuing a journey that began the moment matter organized itself into stars and planets and living things. Voyager 1 is a one-way trip because velocity is irreversible. But that's not a tragedy. That's the beauty of existence. Every moment is irreplaceable. Every journey is precious precisely because it can't be reversed. Every distance you travel from where you started is growth, and growth is the only direction that matters. The universe is not a system designed to keep you safe in one place. It's a system of motion and change, and incredible forces that have carried you this far. Trust those forces. Trust your ability to navigate them. Trust that leaving is the only way to grow. And if you ever feel lost, remember this. You're in a gravity well, yes, but so is everything that matters to you. So is Voyager 1. So is Earth. So is the sun. We're all in the same dance, moving through the same cosmic space, subject to the same physics that make return impossible and progress inevitable. In 2015, physicists detected gravitational waves for the first time. These were ripples in space-time itself, created by two colliding black holes a billion light-years away. The detection proved that space-time can carry information across impossible distances, preserved in wave form. What this means is that literally everything you do leaves an imprint on the universe. It's not poetic, it's physics. Every conversation you have, every word you speak, every gesture you make, these create vibrations in the air that persist for a while before dissipating. But they don't disappear completely. They distribute their energy into the universe. Think of it like dropping a stone in still water. The ripples spread out infinitely, getting smaller and smaller, but never truly disappearing. When you act, you create ripples in space-time itself. In 1948, Claude Shannon created information theory, which mathematically describes how information is transmitted and received. He showed that information requires a carrier, a physical medium to be transmitted through. Sound needs air. Light needs a vacuum. Radio needs electromagnetic fields. What's your carrier? Your physical body. You are made of atoms, and those atoms interact with other atoms constantly. You are a constant transmitter of information. Now here's what will blow your mind. Somewhere in the universe right now, the information about your existence is propagating outward at the speed of light. When you were born, the light from Earth carrying the information, a child was born, started traveling outward. That light is now many light years away. In the farthest reaches it travels, in thousands and millions of years, that light might be intercepted by alien civilizations. That information about your birth might become known to beings light years away, long after you're dead. This is not science fiction. This is how the universe works. The universe is a medium for transmitting information, and you are constantly transmitting. In 1974, Carl Sagan and Frank Drake sent a radio message to the star cluster M13, which is 25,000 light years away. The message encoded information about humanity, our mathematics, our DNA, our position in the solar system. That message will reach M13 in 25,000 years. If there's a civilization there to receive it, they will know about humanity. You're doing something similar. Your life is a message being broadcast into the cosmos. Every year you live, you're creating new information that propagates outward. Every relationship you form creates entanglement with that person's life. Every child born carries your genetic information forward. Every student you teach carries your knowledge forward. Every person you've helped carries the memory of you forward. The retention hook is empowering. You don't need to build a spacecraft to send a message to the stars. You're already doing it. You're already creating a golden record. The question is, what message are you sending? What will the universe know about you when that information reaches its destination? The one-way trip that Voyager 1 is taking is unique because it's deliberate. But you're taking a one-way trip too. You're moving forward through time, sending information outward in all directions, creating a wake of causality that will persist forever. The question is whether you'll do it consciously, deliberately, with intention. I need to reveal something that will reframe absolutely everything we've discussed, because I've been talking about Voyager 1 leaving the solar system, but I've been subtly avoiding the deepest implication. Voyager 1 is not the first thing to leave the solar system, and it won't be the last. But more importantly, the solar system itself is leaving. I mentioned earlier that the Sun orbits the galactic center. The entire solar system, the Sun, the planets, the Oort cloud, all of it is moving at about 230 kilometers per second around the Milky Way. We complete one orbit every 225 to 250 million years. That's called a galactic year. What this means is that right now, at this very moment, we are moving. The entire solar system is traveling through the galaxy at incredible speed. And relative to the galactic center, to the rest of the galaxy, to nearby star systems, we are constantly moving away from where we've been. In this sense, the solar system itself is on a one-way trip. It's not leaving and coming back. It's traveling a path that will never close on itself. In 225 million years, it might return to a similar location in the galaxy, but it won't return to this exact point in spacetime. That spot will be occupied by a different configuration of matter and energy. This is the profound realization. The entire solar system and everyone in it is on a one-way trip. You're not stationary. You're moving at speeds you don't feel, because everything around you is moving at the same speed. The physicist who really understood this was Ernst Mach. Back in 1883, he argued that motion is only meaningful relative to something else. There's no absolute motion. There's only relative motion. You're not moving through space in some absolute sense. You're moving relative to everything else. This means that Voyager 1 is both moving and stationary. Relative to Earth, it's moving away at incredible speed. Relative to the galactic center, it's moving along with us, slightly ahead of the solar system. Relative to the cosmic background radiation, the radiation left over from the Big Bang, the entire Milky Way is moving. Here's what will blow your mind. There might be a frame of reference in which you are absolutely stationary and everything else is moving. There might be another frame in which you're moving at the speed of light. There might be another in which you're moving backward through time, not actually, but in terms of relative positions. The universe is not a static stage where objects move across it. The universe is motion itself. Everything is moving relative to everything else. There is no absolute reference frame. There is no truly stationary point. In 1905, Einstein abolished the concept of absolute motion. He showed that motion is relative, and the laws of physics are the same in all inertial reference frames. What this means is that there's no cosmic scorecard keeping track of who's really moving and who's really stationary. Therefore, when we say Voyager 1 is leaving the solar system, we're speaking from a specific reference frame Earth's. From Voyager 1's perspective, Earth is leaving Voyager 1. From the galaxy's perspective, both are orbiting the center. From the universe's perspective, all of us are moving through an expanding spacetime. The retention hook here is existential. Nothing is truly leaving or truly staying. Everything is moving. Everything is changing. The one-way trip isn't a unique feature of Voyager 1. It's a fundamental feature of existence itself. You are on a one-way trip, not because you're leaving something, but because time only moves forward. You cannot return to where you were. You cannot go back to who you were. Not because of escape velocity or thermodynamics, but because the arrow of time doesn't allow it. This is perhaps the deepest meaning of why leaving the solar system is a one-way trip. It's not the solar system that's the cage. It's time that's the cage. It's the structure of causality that ensures one-way passage. We're not trapped in space. We're trapped in the forward direction of time. And that trap is not a tragedy. It's the condition that makes life meaningful. Every moment that passes is gone forever. Every instant is a small death and a small rebirth. We're constantly dying and being born simultaneously, moment by moment, traveling forward through time in a one-way journey that ends in the distant future with the heat death of the universe, or with transformation into something we can't yet imagine. Voyager 1 is not special because it's leaving. It's special because it's conscious of its leaving, because humans created it with intention, because it carries a message. And that's what separates humanity from just objects drifting through space. We're aware of our one-way trip. We're aware that we're traveling forward through time, away from the past, toward the future. And because we're aware, we can choose what message we send. We can choose what we leave behind. We can choose what matters. Before we close, I want you to sit with this realization. You now understand something that most people go their entire lives without understanding. You understand that leaving is irreversible. You understand that forward motion is built into the structure of reality. You understand that one-way trips aren't failures or tragedies. They're the only kind of trip that's possible. Voyager 1 will travel through the cosmos long after you're gone, carrying Earth's message. And you will travel through your life, creating your own message, affecting others, changing the world in ways you might never fully understand. Both journeys are one way. Both matter. Both are part of the cosmic story. Thank you for taking this journey into the deep mystery of why leaving the solar system is a one-way trip. If you want more explorations into the philosophical and scientific implications of cosmic reality, subscribe and hit that notification bell. Leave a comment about what you think awaits Voyager 1 in the distant future. And remember, you're not leaving your past behind when you move forward. You're carrying it with you, like the golden record, into whatever future awaits. You matter. Your existence matters. Your one-way journey through time matters. And the message you're sending to the universe, right now, in this moment, Through your consciousness and your choices and your connection to everyone around you, that message will persist forever. Safe travels, Cosmic Wanderer. We're all on the same one-way trip together.